Yes. So let us start with the next lecture, that is how to calculate average rate of reaction and instantaneous rate of reaction and instantaneous rate of reaction. So we discussed in the last lecture about the average rate and the instantaneous rate. Instantaneous means the reaction rate of reaction in that moment, and average means the overall rate of the reaction. So the rate of the reaction must be positive. Remember this, rate of reaction must be positive. It must be positive. Now many reactions involve different number of moles of various substances. It means the stoichiometric coefficients of the reactant and the product, it won't be same in a reaction. So in such reaction, various reactants are various reactants are consumed at different rates. So the rate of consumption of this reactant might be different. And obviously the various products which are forming, so the various products are formed at different rates, So the rate of formation and rate of the consumption, it is different. For example, like this reaction, nitrogen reacts with hydrogen, 3 moles of hydrogen, 1 mole of nitrogen to give 2 moles of ammonia. Okay, this is the gaseous reaction. Now the rate of consumption. Now you can see here there are 3 moles of hydrogen, 2 moles of ammonia are formed when it reacts with 1 mole of nitrogen. So the rate of consumption of H2 is thrice. It is thrice, 3 times the rate of consumption of N2. Isn't it? It is very clear from the reaction. Rate of consumption of N2, that is nitrogen. This is one point. Second thing you can write by looking at this reaction, the rate of formation. Whenever you talk about the chemical reaction, some amount is consumed and some amount of the product it will be formed. So the rate of formation of ammonia, it is twice. You can see here, it is twice 2 moles of ammonia are formed. It is twice the rate of consumption or disappearance, consumption of N2. So it is very clear, these two things are very clear by looking at the reaction. Now the rate of reaction must be same. So for this, the rate of reaction must be same irrespective of the reactant or the product selected to measure the rate of reaction. Whether you select any product or whether you select any reactant, the rate of the reaction should be same. Therefore, the rate of the consumption. Okay, so here what can be done? So the rate of the consumption, I'll write in the same on the same slide here itself. That is this is important sentence to solve the problem based on this. So the rate of consumption of a reactant. What is consumed here? Reactant is consumed. Of a reactant or the rate of the formation of product. What is forming? That is obviously the product is formed. Rate of formation of product. It should be divided by. It is divided by its stoichiometric coefficient. Its stoichiometric coefficient. Stoichiometric coefficient in the balanced chemical equation. The reaction should be balanced. Of course, the reaction should be balanced. So this is important. It is divided by stoichiometric coefficient. So these are the stoichiometric coefficient. Here it is 3, here it is 2, and here it is of course 1. Okay. So what does it mean actually? So we'll be solving the problem based on this. So you'll be more clear with this. But just looking at the reaction, you can say rate of consumption of hydrogen. Here it is hydrogen. It is thrice the rate of consumption of N2 because there are 3 moles of hydrogen it is consuming with respect to 1 mole of nitrogen. And 2 moles of ammonia it is forming by consuming 1 mole of nitrogen, isn't it? So if you, I mean, these two statements were written with respect to this nitrogen, isn't it? So while solving the problem also, the data is given in such a way that looking at the reaction, only one thing is given, and with respect to that given thing, you are supposed to solve the problems. Okay, so this will be more clear when you actually solve the problem based on this. Here we go to the next slide. Now, here I wrote one reaction here. N2O5, it is converting into NO2 plus O2. Now the average, one more point is I missed here. Here one more thing should be explained. Wait a minute, I'll add one more slide here and we'll talk about this. Now, I told you about up till now we have studied this thing. So in continuation with this reaction only, how will we write the average rate of the reaction for this particular reaction? This is the reaction in front of you. Okay, I'll write it again. N2 plus thrice H2 in gaseous medium. This is a gaseous reaction and it is getting converted into twice ammonia. Okay. Now, to write the average rate of reaction for this particular reaction, average rate of reaction, you can write for this one as equal to minus, as I told in the earlier lecture also, this indicates minus sign indicate that this is the concentration of N2, it is consumed, and delta T. This is equal to, as I told that it should be divided by its coefficient. So what is the coefficient for this H2 here? This is 3. So this concentration should be divided by 3. So you can write here minus, again there should be minus sign, minus 1 by 3 delta concentration of H2 divided by delta T. Okay, and this will be again equal to, here there is only one product, that is twice NH3. So it should be divided, the concentration of this NH3 should be divided by its coefficient. So you can write here half 1 by 2 and delta concentration of NH3 divided by delta T. So this is the way you can write the average rate of the reaction, isn't it? So we'll be looking for this calculation of average rate of the reaction by taking some other example. You can, if either of the rate consumption or the rate of the reaction is given, you can solve the problem based on this reaction also. But I chose another example for this. But this is the way that you will be able to write the rate of the reaction equations. Okay, so why do I put here 1 by 3? Because this 3 is the coefficient, stoichiometric coefficient for this H2, 3 moles, and it should be divided by 3. So that is why I wrote here 1 by 3. So this negative sign indicates that this is the amount of this hydrogen concentration it is getting consumed. Here also this negative sign means N2 is getting consumed. And here there is a plus sign. It means that NH3 it is formed. Okay. Now just let us solve the problem, another one on the same lines. How will you, if the data is given, how will you calculate the average rate of the reaction? So I took the another example. This is the reaction in front of you, N2O5. This is the balanced chemical equation given to you, and the concentration. What are these? These are the concentrations of, I'll put this row like this. These are the concentrations of the N2O5, NO2, O2, like this, at different time intervals. Okay. Now, in this first column, you can see this is the time. So in the beginning of the reaction at 0 time, this is the concentration of N2O5, and so on. So in this way, you can read this table. This is the given data. After 200 seconds, if you look at this column, you can see there is a continuous decrease in the concentration because this is getting consumed. Okay. This is the concentration of NO2. So obviously product is forming because NO2, it is the product side. So it should go on increasing. So you can see there is a continuous increase in the concentration of NO2 with increasing time here. And O2, it is also forming. So there is also a continuous increase in the concentration. M is moles per dm³. Okay, molarity this is. Now, how will you calculate the average rate between, if you are asked to calculate the average rate for this particular reaction, average rate between 200 second, S stands for second, to 400 second. How will you calculate this? So to calculate the average rate for such data is given. Such problems is asked in the examination, remember. So how will you calculate the average rate for this? So for this one, I'll write average rate. Average rate, it is equal to, now before that, there should be reaction in front of you. So I'll write the reaction again. Twice N2O5 getting converted into 4NO2, 4 moles of NO2, and 1 mole of oxygen is formed. Okay, so the average rate, it will be equal to minus half of the concentration of N2O5. As I told earlier also, that this minus half, this is the coefficient of this two, so that should be, and this minus sign indicates that it is getting consumed. Okay, so this is equal to, now remember, we'll have to go to the earlier slide. Now at this, we are supposed to calculate the average rate between the second 200 to 400 second. So what is the concentration of this? This is 0.0213 at after 200 second, isn't it? And after 400 second, it is 0.0152. So when you subtract this 0.0152 minus 0.0213, you will get the difference in the concentration, isn't it? So this is the difference here. This thing we have to subtract from this. This value is to be subtracted from this one, because there is, as the time proceeds, there will be continuous decrease in the concentration of N2O5 because this is a reactant here. So what can be written here? So for this, you can write 0.0. These values I am getting from referring to the table itself, 0.0213. So this is the concentration at 200 second, and this is at the 400 second, and this is for the 200 second, after 200 second. It should be divided by 2 into delta T. Delta T means difference between the time, that is 400 second minus 200 second. Okay, so if you solve this whole thing, I did this already, so I'll be directly writing this 1.525 into 10 raised to minus 5. This is very simple calculation. You can do on your own also. This is moles per second. This is molarity per second, or moles per dm³ per second, you can write. Now, average rate, this is also equal to, so how many moles of NO2 are formed here? There are 4 moles. So you can write for this, we'll go to the product side now. 1 by 4 change in the concentration of NO2 divided by change in the time. So again, you can go to the table. Now, if you go to the earlier slide, so now we want to know the concentration for the at 400, after 400 second it is found to be 0.0296, and at 200 second it is 0.0174. So if you subtract this from this and if you substitute here, you will get, that is 0.0296 minus 0.0174 divided by 4. Now, from where do I get this 4? This is 4. So this 4 into delta T would be 400 minus 200, because we are supposed to calculate the change in between this range. Okay. So this again, if you solve this, you'll be getting the same answer, 1.525 into 10 raised to 5 moles per dm cube per second. Okay. Now the average rate again can be calculated for the, this is for the average rate for the formation of NO2. This is for the average rate for the consumption of N2O5. And this is the average rate for the formation of O2. Now we are left with this. Now for this you can write, since there is only 1 mole of O2 is formed, so you don't have to multiply or divide it by any coefficient. You can write for this. So this will be equal to, again go to the earlier slide. So at this, now look at this. Look at the third column here. So this is the value after 200 seconds. This is the concentration after 200 seconds. This is the concentration of O2 after 400 seconds. So subtract this concentration from this. So 0.0740 minus 0.0435 divided by 400 into 400 minus 200. So I write here 0.000740 minus 0.0435 divided by 400 minus 200. You need not have to multiply here because there is nothing. There is only 1 mole of O2 is forming. So the coefficient is 1. So here we have multiplied it by 2. Here we multiplied it by 4. So here it should be multiplied by 1, means it is the same. So if you solve this, you will get the same thing, 1.525 into 10 raised to 5 molar per second, or this is nothing but moles per dm cube per second. Remember, okay, the unit is this. Now, if you look at this carefully, you will see every time whatever is the amount of the rate of the consumption of N2O5, it is found to be this one. Rate of the formation of NO2, it is this one. And average rate for the formation of O2, it is again the same. With the average rate of the reaction, you are getting here the same, though there is change in the concentration at respective times. Understood this one? So in this way, you can solve the problems based on the average rate of the reaction. Okay, now next we proceed for the instantaneous rate of the reaction. How to calculate the instantaneous rate of the reaction? No doubt the data will be given to you, and based on data given, we are supposed to calculate the average rate of the reaction and instantaneous rate of the reaction. Now for this instantaneous rate of the reaction, I'll take the same example again, and then we'll solve the problem based on this. The same reaction you can write. Now the coefficients are again here important. So for this instantaneous rate at time t, means in that particular time t, whatever is at that particular moment, what is the rate of the reaction? So that is why we introduce the derivative term. Derivative means at that moment, we replace this delta by dt. So the instantaneous rate of the reaction will be, I can write here, instantaneous rate of reaction at time t, in that particular time, reaction at time t can be written as minus d dt of concentration of N2, isn't it? This will be equal to, this is equal to minus 1 by 3 d dt of concentration of H2. Now by this time, you should be able to understand why I am writing minus 1 by 3, because this is the coefficient. And minus sign means that this much moles of this hydrogen, it is getting consumed. Okay. Now this again will be equal to, we can write further, half d dt of ammonia, concentration of ammonia, because there are 2 moles of ammonia it is forming. So this is the way you can write the instantaneous rate at particular time t. Now in general way you can write generally if the reaction is given like this: A moles of A, small b moles of B, small c moles of C product, and small d moles of D. So you can write for the rate of reaction for this particular reaction as minus 1 upon A. This is the stoichiometric coefficient. d dt of concentration of A equals to minus 1 upon B, d dt of concentration of B, I hope you are getting me, equals to 1 by C, d dt of concentration of C equals to 1 by D, d dt of concentration of D. So this is the way, this is the general way of writing the instantaneous rate of the reaction. Now, how do we apply the same thing to any given problem? So let us solve one problem based on this so that you will be more clear with this thing. Now, if the problem is given this way, this is the reaction given to you. Twice NO plus O2, NO means nitric oxide, reacting with oxygen to get 2 moles of nitrogen dioxide. So for this reaction, the rate of consumption of nitric oxide at a particular moment. So when it is given as a particular moment, so you should understand that you are supposed to calculate the instantaneous rate of the reaction. So it is given as 0.065 molar per second. Now you are expected to calculate the rate of formation of nitrogen dioxide, means NO2, and the rate of consumption of oxygen, and the rate of reaction at a given instant. So we'll solve one by one. Okay. So how will you go for this? Actually, now how to approach for this such type of problems which is given. Now just concentrate on the thing which is given. This is given thing to you, 0.065 mole m per second, moles per dm cube per second, isn't it? That is the molarity per second. Now this is the given thing to you. So write this first. This is minus d dt of concentration of N, isn't it? And this is given as 0.066 moles per dm cube per second. Instead of capital M, you can write this also. Okay. Now, you are supposed to calculate the first thing. What is that? Firstly, what is asked? The rate of formation of nitrogen dioxide. So, rate of formation of nitrogen dioxide. So, whenever I say formation of nitrogen dioxide means there should be plus sign. Isn't it? The concentration of this product, it is obviously getting increased. So, d dt of this NO2, this is equal to minus, how will this be formed? How will this nitrogen dioxide is formed? By consuming the reactant here. So what is given here? This is given. Okay. So you can compare this with this thing. So this will be equal to minus d dt of NO, concentration of NO. We are not aware about the rate of consumption of oxygen. So we need to compare this formation of nitrogen dioxide with this thing, this quantity only, which is given to you. Okay. So here 2 moles of nitric oxide is consumed or utilized to get the 2 moles of nitrogen dioxide. So 2 by 2 means their coefficient will be 1. So this rate will be equal to this one only. You need not have to divide by any coefficient here. So that is will be equal to 0.066 moles per dm cube per second. Okay. Now this is one thing. Second, we are expected to solve the rate of consumption of oxygen. Now, rate of consumption of oxygen. How will you calculate this? Rate of consumption means there should be minus sign d dt of concentration of O2. This is expected to be calculated. So this will be equal to minus. Now again, the given data is this one only. That is the rate of consumption of NO, nitric oxide is given. So we need to compare this with the rate or the data which is given. So write this minus d dt of NO, isn't it? Now only thing here, you need to add here minus half because there is 2 moles of NO and there is only 1 mole of oxygen here. So you will be writing in this form. Okay. Now what is this for this one? What is the value? This is 0.066 and it should be half into half. So you are getting here answer at 0.033 molar per second or moles per dm cube per second. Okay. Now we got these two things, rate of formation of nitrogen dioxide and rate of consumption of oxygen. Here we got these two answers. Now, if you concentrate or if you look carefully, what did I do? I just concentrated on the given data and compare this given data with the reaction coefficients and then try to find out it. It's very simple. Now what is left to be calculated? The third thing what is asked here, the rate of reaction at given instant. Now for this one, I'll go to the next slide. The rate of reaction for this. So now for this particular one, the rate of reaction can be calculated as, now what is given again? That is d dt of NO, rate of consumption of NO, it is given in the problem. Okay, now this should be half because there are 2 moles. So this will be equal to half of the rate which is given, that is 0.066, and that will be equal to 0.033 moles per dm cube per second. This is your rate of reaction. Rate of reaction, I directly made this by just looking at the concentration of consumption of nitric oxide because this is given to me. Okay, and how many moles are there of this nitric oxide? That is 2 moles. I'll write the reaction again. Okay, so here O2, this is your reaction. So since there are 2 moles of nitric oxide, that is why I divided it by the coefficient. Stoichiometric coefficient is 2. So that should be divided by, so I multiply it by half. Isn't it? So this is the way you are supposed to solve the problems based on this. Now, this is about the how will you go for the solving the problem. We'll be solving more problem based on this. Just I wanted to share that how can you calculate average rate of the reaction and how can you be able to calculate the instantaneous rate of reaction if from the given data.